Well, thank you. I have my notes here. So, good morning. Thanks for coming to attending this talk. My name is Victor Jaques. I work for Igalia, an employee-owned company based in Spain. So we are spread among the world. We work on graphic stack from the kernel up to Mesa and alike libraries. We do multimedia. We are the main contributors of GStreamer. We do compilers, mainly JavaScript and LLVM. But our bulk of the business is web browsers. We are the top, the second biggest contributor in Blink and Chromium and WebKit, behind Google and Apple, obviously. And we are a major player in Gecko also. Well, personally, myself, I'm a GStreamer maintainer and a WebKit committer for the multimedia stack for the GTK and WP ports. WP is a web engine oriented for embedded, and it's installed in millions of set-top devices and other appliances. As a side note, hopefully for future Vulkanized events, we could increase the gender diversity of the speakers so we can grasp a better view of how the Vulkan is used and deployed in the world. Now, okay. Well, the purpose of this talk is to share with you the experience of adopting the Vulkan video extensions in GStreamer and FFmpeg. It's fair to say that they are the biggest open source multimedia frameworks. For those who are not familiar with GStreamer, which said it's a set of libraries for multimedia application development based on the pipes and filter pattern, while FFmpeg is a monolithic multimedia Swiss knife, to say it in a way. I'm not a contributor of FFmpeg, but I do follow it. And lately, I'm a huge fan of Lynn, who has been doing an impressive work with implementing Vulkan in FFmpeg. And finally, if we have time, we show some demos, if the Murphy's law allows. Well, regarding the Vulkan Video API, I could say, in my opinion, it's a semi-stateless video processing API. Back in the days, video processing was stateful. That is, mean that it was a black box. You put inside, you push a bit stream, and you receive raw frames. But wasn't at the end a good idea, because it can be risky in terms of hardware, and it's costly in terms of, for example, kernel operations. So nowadays, most of the video processing APIs are stateless. This means that you have provided by each frame all the work, all what is needed to be processed. So basically, the application must to handle the state of the stream processing. So basically, I would say that the Vulkan API is very low level. It means that you have to specify what are the resources are you going to use, the memory, the devices, or what are you going to use for the stream processing. In other APIs, stateless APIs, you don't have to worry about that. So this is very fine, and also this is very fine-grained to mean that every vendor can choose for different ways to process the stream. That's something that was explained by Tony, that AMD can do something for the DPV, NVIDIA another thing. So if you want to implement a generic video processing using Vulkan, you have to recognize what the hardware asks to you to do and implement it, of course. And also, well, the API is very verbose. You have to specify a lot of things, and the specification is huge. So I'm not a Vulkan developer myself. I just started for my part-time last year, and still I cannot process the whole spec yet. we're going to start now with the nuances of the problems that we have found adopting Vulkan video in already pre-existing APIs or internal APIs for FFmpeg and GStreamer. GStreamer and FFmpeg internal API for hardware accelerated processing assumes that each frame has to be completely defined with all the sequence parameters, picture parameters, video parameters, each slice, and so on. This allows them to the libraries to fix parameters in, for example, flaky or erroneous or strange streams. But in the case of Vulkan video, is different. In order to limit the transfer of data from the CPU to the GPU, it allows to specify all those parameters once, because it's going to be shared among the stream or a segment of the stream. So this is like a mismatch between the APIs. In the case of FFmpeg, Link prefer to upload the parameters by each frame, as is used in the other hardware accelerator APIs, because FFmpeg does a lot of work trying to fix the wrong parameters. In my case, I added a new API, which is not merged yet, in our base classes in order to post the new parameters every time it's found in the stream. So I can test this functionality in Vulkan. Well, now regarding this, the DPV has been my headache for many days. So basically, roughly speaking, is to reconstruct an image, it might need other images that were already decoded in the past. That's what we call the DPV. A vendor can specify how it handles the DPV, something that already Tony explained it. Right now, there are two ways to handle the DPV. The output images are also used as references. This is A. And B, the references images in the DPV are different from the output ones. In this mode, we have two different modalities. B1, each reference is a single VK image, and B2 is each reference is a layer in a common image. So basically, depending on how your hardware or your vendor allows and how your stream is constructed, you can choose for one or another. And also, you have a generic implementation. You have to query the hardware and decide what to use afterwards. Well, another nuance is that's what I'm saying, that perhaps Vulkan video is a semi-stateless, is because we have to, and this is my current issue with GStreamer, is that we have to keep an index per the whole DPV existence. So that because there is a pair of index, slot index and the image, and that is part of the global state. So the problem is that GStreamer doesn't keep that index. It just delivers the whole DPV and it's delivered to the hardware and processes. But we have to keep the slot index among the time. So that is something that FFmpeg solves easily, because they use an array for the DPV, and the pictures vector are reused in the next or recurrent element. So that's no problem for FFmpeg. In the case of GStreamer, we have a lot of headaches, and you might see in the demo. But we are towards solve that issue. Well, in the case of bitstream buffers, each encoded frame is composed by, beside the parameters that we already talked, by slices. And the slices contains of macro blocks and all that stuff. FFmpeg and GStreamer internal API for video decoding or video processing assumes that each slice is going to be uploaded at time. But that's not the case for Vulkan video. Vulkan video asks to upload all the slices at once for the frame. That reduces also the communication between the CPU and the device, the hardware device. but it asks us, or the application, to do a memory copies if we are not holding the whole, because we had to hold all the slices, while the parser just deliver the parser and then delete the data. Lean in FFmpeg solved that issue using the extension of external memory host. So basically, they are just doing one memory copy to the host, but in our case, we had to copy the slice and keep it around until we push the whole frame. And another issue, a strange issue with Vulkan Video, is that each slide must be prefixed with the slice start codecs to say 001. FFmpeg and GStreamer per each slice just deliver the slice. It doesn't prefix the start code. So we have to manually add the start code before pushing to pushing the whole all the slices. So each slice has to be prefixed. That's something that is not used by other hardware-selected processors. Well, and multiplanar images. Vulkan is RGB oriented, while the video world is YUV oriented. Vulkan used to emulate YUV with multiple RGB images, which compose each plane of the YUV format. That's not efficient for video. That's why there are new YUV formats were added. For example, this one, the G8B8RA to plane 420, which maps in the video world to the MV12 format. But now we have two ways to represent the MV12. And that's a strange mapping, because we have to specify in our internal APIs for either GStreamer and Vulkan, we have to specify the usage of that image. It's going to be used by DPV or by the encoder or by the output of the video. We have to use the one planar, this format. Otherwise, we choose the two images per frame. And nowadays, it's solved with hacks. Basically, we enable video. We're going to use this one, and we'll lose the backward portability. So it's something to be solved for before merging this. And that's a challenge. Finally, this is the last slide before the demo and questions. GStreamer, this is a case only for the GStreamer. GStreamer have to register all the available elements and its capabilities. So the user can construct the pipeline he wants. So he introspect the registry, say, okay, this element has this property, so I can plug this element through this element. And also it's used by the auto plugin mechanism, so we can choose the next element in the pipeline on the run. In order to do this, we have to query or to open a Vulkan video session and set the profile to check if the hardware supports it, and by a try and error iteration, find out all the capabilities there is the physical device and the queue is capable of, and register each element that is possible to handle the video decoding. And this has not have been solved yet, but it's an open problem. That's it. Thank you, and let's try to do the demo if that's possible.
Yes. Let's try to move the screen. I guess that's a lot of information here. So yeah, like the last few months, we have been working together, like to implement Vulkan Video into GStreamer. We succeed to have like something to be demonstrable. Here we're having a pipeline. So in GStreamer, we're having pipelines with like black boxes. So from the beginning, the video test SRC is like just a source of the video. It's going to be a pattern, like a test pattern. And then we can see with the time overlay the number of the frame number. And then we encode with OpenH264, we decode with Vulkan, and we present it with the auto video sync. So from there, we can see that we are displaying something, but it's a bit slower on Google Meet. But yeah, the idea is like to demonstrate that now we are able like to decode iframe, but we still like having issue with the DPB handling. That's why you can see like artifacts in the playback.
So it's slow because we download to CPU memory.
No, it's slow. Here it's the same speed, but because of Google Meet, I would say.
Okay,
that's why live it's complicated.
But even so, this is slower. If we present directly the image, it will be faster. Nowadays we are downloading and copy to them.
That's a test pattern, and then we can also demonstrate with a real-world video. So it's the famous Big Bug Bunny. So I have to start it over, and then so play, and you can see here like we're having more artifacts problem because of the DPB handling still, but we can start to see something on the screen. It's like yeah, we're gonna handle it. This DPB. So we're gonna demonstrate the other one.
Should I shut down the session?
Yeah, probably, and then
keep it. Yeah, exactly. Keep it.
So, in the meanwhile, we set up this other thing. Any questions?
Yes. Yeah, I can answer the question if you want. We haven't tried NV for now. We haven't been checking so much the performance right now because we want to achieve the decoding and then like optimize the decoding process. Right.
there you go.
No, this is not.
Can you speak a bit louder because I'm not sure to hear you. Can you speak a bit louder?
This is going to be.
To gain from the already hardware accelerated decoder, I don't know. I would say that it's more a question for Tony. But definitely, yeah, regarding like a software accelerated software, we are expecting like something much faster.
Just to answer the question. So FMPEG already has a better performance.
Yes, I want to show that.
We already done benchmarking with that. Now, complexity, it's quite complex API. This API is not actually meant to be used top level. It's supposed to start with, like, those guys have a lot of pain implementing. We'll sort it out. And then if you use GStreamer, this is your middle one. You could already use FMPEG, for example. Or you could actually use the libraries, right, which you have like the sample libraries. The library, the way it works is that you could actually just initialize the parser and the decoder. You say, give me next frame, and put it in display. Or you could even just say, okay, put it in display. Then this would be your starting point, and then you start looking at the, okay, for example, I'm using too much memory, or using
Your camera.
I need less, for example, latency and so forth and so forth. Then you could actually start tweaking stuff around, right? So, but in general, this is very low level API. This is very down to hardware, and it's not something like you push it out and everybody starts like doing applications. So you better use the library. That's why we spent all this time, creating libraries and working with Italia to support GStreamer.
Yeah.
And so
also do.
Yeah, but basically a demo with FFmpeg, running the Granite library, which grabs the frames from FFmpeg, which are the BK images, and presenting them. And also it has it's a demo just, so you can also do some transformation here and some here and there.
So yeah, do a playback inside a texture. Yeah.
And so if I may just address your question about the performance.
Yeah,
Now,
perfect.
if you compare
But want to say
the
some time.
other APIs in the market, you could probably achieve the same frame rate because the same hardware tools. But one thing you're going to notice is that when you start dealing with presenting stuff on display, since things are, so in Vulkan video, whatever it comes as a YCBCR image goes as a texture, right? With other APIs, you say, okay, I've got the frame rate now, I have to put it on display, so I have to use interrupts, I have to think about changing layouts, copying images, and so forth, right? So Vulkan video, in this case, is going to help you with when you download the frame, you're probably going to be on par with the rest of the APIs, but then when you put it on the display or going to graphics, you're going to get much less frequency. You're going to use the same queues, you're going to use the GPU to synchronize all the way. And sorry, I couldn't actually finish those slides pretty much.
We are merging the
Yes, by the
presentation.
announcement, we'll just take this to the lunch. For the demo.
Okay, so my question is for any of you three. About 11 years ago, I played around a little bit with MPEG for a company that was a little bit too cheap to search for a big video license. And we didn't quite understand the patent licensing model around stuff like NVNC. So we just went on with like VP9 just to not have men in suits show up at our door. And my question is, if I'm using something like Decoded, who is the person that has to cover the patent stuff? Is it the IHV, or do I kind of have to?
So one of the reasons, so one of the reasons why we had to do the API layers is to keep. So first of all, Vulkan is royalty-free API. So whatever goes into the API, you could use it, and nobody's going to come after you. Now, MPEG standards is not like that. So we spent a lot of effort to keep this stuff separate. Okay, so codecs, one of the reasons why we have 264, 65 separate STD files or standard files is it's actually away from the royalty-free APIs. Now, if you're going to use 264, 65, you're going to have advantage that you actually run develop application once and works everywhere, but you still have to obtain licenses for using 264 and 65. But again, the good news is we're working on AV1 now, so very soon you'll have royalty-free also codec. But yeah, Khronos does not actually provide licenses for using 264, 65. This is if you already have licenses, if you have solutions. Most of the mobile vendors, most of the people who use codecs, they already have licenses. All they would probably need Vulkan for is that they need low latency, more control over memory, more control over processing, more control over everything, right? And you have like more optimal solutions.
Yeah, and also it's still the same with other hardware accelerator APIs, like the API, B4L, B4L2 in the kernel, and so on.
Video toolbox. Yeah.
So in interest, because I know we're way over time, and we're going to try and cut the next break short to like 10 minutes, and then we'll probably have to eat into our lunch for the following sessions too, unless people can present faster. So let's take a quick 10-minute break, and then we'll rally back here and get started with the next session.